Okay, there we go. We are back, and that's fantastic. Okay. So, like I tried to say, but didn't work initially because microphone was done, or not done, not set up. Cool. Let me know if it's working now. Great, great. So glad. Thanks, Ragva. Uh, the- um, yeah, right. So we are gonna look at Spark pushdown, and so filter pushdown and really query pushdown in general. But I'm pretty sure this is just a filter pushdown issue. My memory's a little fuzzy. Edge case. Anyways, we're gonna go look at an edge case that's came up at work, and we're gonna try and see if I can make this like work-ish. I don't know. TBD, TBD. But essentially, yeah. So we're gonna go from there. I'm gonna get my little treadmill going. There we go. Cool. Doot, doot. Oh. Doot, doot. 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 Okay. Right. So I think I put the Jira. I did. Yes, predicate pushdown. So we're gonna be looking at really. I think we're just gonna be looking at filter pushdown. And so there's like this very specific sort of weird edge case that we came up with, and I haven't seen anyone else running into it, which makes me think we're doing something weird, which is almost always the case, just to be clear. Okay, git checkout master, git pull, and wait, really? Oh no, git remote, git pull Apache GitHub. There we go. So I have not done a pull on this box in a while. Cool. Build SBT, key 5, and go clean compile test. For good luck, also known as like I prefer to know like when the thing that I'm doing is working. So that's good start. What was else? Right, okay. We're gonna do an Emacs because machine rebooted during the power outage that we had in California semi-recently. Oh, damn it, disown didn't do the trick. Oh, no, it did? Great. It just took a minute. Ugh. I really need to change my .emacs to not try and do that. Let's do that. Val buffer, does this do the trick? Yeah. Okay. Okay. Spark, no, okay. Repos, Spark, there we go. Oh, not good. Not good. That's not great. Let's go clean. Compile. What failed? Oh. Oh, okay, what's my Java version? Yep, Java 11. Apt cache search JDK 17. I have not worked on Spark on this computer for a hot minute. Okay. JDK 17. Sure, why not? Now, this is an issue that I ran into in Spark 3.3, which is the version that we're running at work. And it's possible that the issue's already been fixed in upstream. I didn't see any changes to the parts of the code when I was looking at the Git log around the optimizer there. Doesn't mean that there wasn't though. So, well, we'll take a look. Okay, fucking hate computers. /boot star 6.2 star /old boot. Dude. Drink some water too for good luck. I feel like this is the definition of yak shaving, right? Like we're trying to compile a Scala project, and so I had to update my JDK, and updating my JDK meant that it also updated my kernel, and updating my kernel meant that I ran out of space on /boot. Which I don't love. Oh, okay. Which Java class user in Java? Let's see alternatives. Java, okay. Update, sudo update, alternatives, Java? Okay. Let's go look that up because I literally don't remember. Update, alternatives, JDK 17, Ubuntu. And then we'll do Java C afterwards. Okay. We want to use 0? Yeah. And then 0. What? Java. That's export by Java underscore? Build SBT. Okay. There we go. Third time's the charm. Okay. Great. So the thing that I'm looking for is optimizer.scala. I think it's inside of optimizer. I don't super remember. My memory is not great. Let's go take a look. So the thing that I'm looking at is semantic Okay. Push down. Yeah. Yeah, this is looking about right from my memory, which is to say, so it's push down predicates through non-join, and that, my friends, optimizer.scala around, was it through non-join or through join? I don't know. Yeah, okay. And so it's going to be the filter one here. Filter. Oh yeah, okay, and this is the filter. So what this does is aggregate copy. Where's the assertion? Sorry, this is filter condition aggregate. No, this is filter condition union. But in general, yeah, here we go. So here we've got our new condition is picked using semantic equality, and then we have this assertion that is not using semantic equality. And semantic equals is like, that's a Spark thing, not a Java thing. Or, yeah, I think it's a Spark thing. And so, interestingly, I'm curious, do we do the same thing up here, right? Do we have... Where's the other assertions inside of this code? Interesting, the only one with an assertion is this one. Or I shouldn't say the only one. It looks like the only one with, yeah. The only filter pushdown with an assert is this. So this is 1789 and optimizer.scala. Oh, cool. Doesn't work. I love it. I'm glad we did this before I made any changes. Okay. Let's run compile. Probably I've got a dirty working tree. Yeah, I've got a dirty working tree. Wait, let's take a look. Make sure this is, yeah. It's at add hard. Delete. All of these. Build /zinc. Get status. Logs YAML. QE. And build. What else is that? Oh, I didn't mean to do that. Let's go. Build.log rm. I guess actually I could do this. And then we'll do reset hard, get status. dev, hide code style, driver log, exec log, flake.sh, flake logs, do cloud. Why is Minikube here? Test tree. Okay. Great. We run clean compile. That we should have a non-dirty working tree. Okay, but essentially, my assertion, or my belief here, my belief, which is about this assertion, finger guns, is this assertion is just incorrect, right? Like, it doesn't need to be there. This doesn't make any sense because the way that we're determining the candidacy and the way this assertion is checking are different. And I don't think that makes sense, but I'm not like 100% convinced. So let's go read some of the code up above, because it's possible that like the way we're determining candidacy is wrong and the assertion is correct. It's going to be one of the two. Okay. So what do we see here? Push filter operators through window operators. Parts of the predicate that can be pushed beneath must satisfy the following condition. Okay, all the expressions are place before any notes. Okay. So here, union can change the rows, so non-deterministic predicate can't be pushed down. No shit. So push down, stay up. If push down is not empty, what do? We get the output of the union. So those are all of the rows that are coming out of the union. And then we've got our push down con. Let's just push down. Has been put together. And then if what we're trying to push down is in the union's out, let's start. Let's add some comments. So new con. Okay, yeah, this is the new grandchildren. For all of the union's children, if they what do we do with new grandchildren? Okay. Union.children.map grandchild. If output exists, semantic grandchild output. So yes, if a child of the union, is semantically equal to if a child of the union is semantically equal to a condition we're trying to push down, then Where's the grandchild go? Ah, okay. Union.children, union.grandchild. Then grandchild.output. Output.index where submit. Okay, then oh fuck me. Wait, what the fuck? Where is this map? Okay, okay. So you are still making the new grandchildren here. And then... okay. If there is anything you can't push, evaluate them post-union. We can't push anything, just return. This is adding comments so I understand what's going on, because keeping track of things in my head is evaluate post-union. Otherwise we can return new union, add a filter on top. If there's any filter, we can't. Okay. New grandchildren. So new cond is then okay. Let's go ahead. So union.children. Let's go take a look at the union class union. Okay, it's going to be basic logical operators. Fantastic. It's union. Okay. So this is just a basic union class. So we get the children. Why is it called grandchild? Oh, because the union is a child of the filter. So the children of the union are its grandchildren. Okay. Fine. Does this make sense? Is that how we use grandchildren later? Yeah. Yeah. The union is the child of the filter. Its children. Okay. Then new cond. So multiple plans without a distinct. This is a union all in SQL. By name. Oh, okay. So if new cond, pushdown transform, pushdown cond. Wait, does this make sense? Hold on. I'm not. Take a look. How do we X rows per partition? Okay. Union children. Okay, output is just all of the children. Output. And then where's the eval? Yeah. Constraints, merge. Okay, yeah, with new children overrides its children. So grandchildren. So here we say new cond is pushdown con transform. And then our assertion is so new grandchildren union.children.map. So new cond pushdown cond transform. This makes sense. Does this make sense? Because we're rewriting the union here effectively. New cond, pushdown cond, transform. Case E, if output exists that is equal to an element of pushdown cond, then the new condition is whatever this was. Okay. Swap all of the children which but otherwise, what's going to happen inside of pushdown cond? New cond is pushdown cond. But what if we don't resolve it? New cond references should be a subset of the grandchild. Ugh. Computers. Okay. So, new cond pushdown transform. If output exists that is semantically equal, then we're just returning the okay. If elements that, okay, replaces all element, okay, gotcha. just return the initial filter. Okay. Okay. I want to go back to optimizer.scala. What's this being called with? So otherwise, return our new union without a filter on top. We push all filters, then the new union. Okay. The union is a child of the filter, so its children are grandchildren. Construct. There we go. Okay. The new. Okay, yes. Here we go. Okay. Moves filters down to the grandchild. Down to the grandchild. If down to the grandchild, if there is an element in the grandchild's output which is semantically equal to the yes, okay. Gotcha. Gotcha. There is an output which is semantically equal to the filter B. Okay. Update the element in the grandchild to be the filtered version. Is this right? Is this right? Is this right? I think no. I think I fucked up. Yes. Update the new cond could be empty, right? Does that make sense? Update the element in the grandchild to be the filtered version? No. No. New cond. Well, new cond is filter cond. Yeah. Yeah. Okay. This sounds right. So then this assertion, to me, it seems like we should be using semantic equality. I'm convincing myself of this. Let's go find the test code for this, because that's really what I want to do. Pushdown, filter pushdown, suite, one pass. Probably filter pushdown suite. So, cool. Yeah, okay. Rows? No. Okay. Let's go. Okay. So let's see if we can find, there we go. We've got a union one. Not huge, but okay. So we'll probably expand on this. Cool. Okay. Taking a while to run the tests, we're gonna Control C out of that. I said Control C out of that. That is not working. Yeah. Fantastic. Slowly convince myself a little bit. Oh, I ran a global test rather than... This is going to be Catalyst, isn't it? No, SQL dash... okay, SQL test only. Filter, pushdown, sweet. So now the question is what? So we would need to make some to make this fail. We need to make something that is semantically equal but not referentially equal. Which is doable, but my memory is bad. But let's get the current test working. Did it actually test anything? No. Catalyst? Yeah. Test only SQL. Catalyst. Optimizer. Filter. Pushdown. Sweet. Finger guns, my friends. There we go. Fantastic. So, yeah, okay. But does this do filter pushdown? Wait, what? Test relation and test relation 2. Oh. Here we go. Yeah, okay, where... B... Gotcha. Okay, this is our original query. And so this is saying that the correct answer here asserts that D is equal to 2. What? Okay, compare plans, optimized. Optimized. Let's go find test relation. Test relation. Okay. Yeah, ABC. Hmm. A is equal to 2. Yes, that part. I mean, does that make sense? Because in test relation 2, we don't have any instances. Oh, no, okay. Where is D equal to 2 coming from? I feel like I'm missing something. This doesn't make sense to me. Right? Like, why are we asserting that D is equal to 2 and F is greater than 5? Are D and F somehow the same here? What the fuck is going on? Doesn't make sense. Okay. Union, test relation 2. A is 2. Oh, maybe. Yeah. Okay. Oops. Okay. Okay. Sorry. I was thinking of it as like a union like loop, schmurp, rather than schmurp. Okay, that makes slightly more sense. Although these are different, so I would expect it to be like schmurp. Oh, right, because it's a union, but it's not a by name union. Okay. Union by name. And then this is going to go away. Right. Or not go away. It's going to become, we don't push anything down here. Make sure that I'm understanding things correctly. Do not normally work inside of Spark SQL, so there is a fair amount of, I don't want to say guessing, but poking around in the dark would be the polite expression. Okay. Ah, no, I'm wrong. Okay. Okay. A and it's going to be, yeah, okay. ABC. And so then this is just going to be, okay, fine. So, There we go, there we go. Sure. I think I want to do some things. Oh, interesting. Where did it differ? Plans do not match. Union false false. Filter over the local relation. Because we've got it by name, so that adds a projection. And these are okay. This is whatever. Not super important. Okay. Sorry. VPN fell over. So I want to go and look up error. Okay, this is making a bit more sense. So, seeing how this came to be, but like the thing is, I want to make a test where this fails, right? And so how do we make that? So let's go take a look at semantic equality. SQL star src. Okay. Semantic equality is inside of expression, and this compares two expressions. So, how do we do this? Okay, semantic. So they both need to be deterministic. And okay, def and okay. Non-kala. Cannot spell. Horseshit. I don't think that's what I was looking for. Okay. Lazy val. Canonicalized is an expression that gives us back with canonicalized children, which on each expression cumulative build canonical. Okay. Basic logical operators. There we go. It gives us a canonicalized view. Subquery. So these are. Oh, fuck. Okay. I have a annoying theory. If we do this with that, work or no? Still gonna have this projection. But if the projection is the only thing that's... But if it fails during the pushdown evaluation, that would be good, but I don't think it's going to. Yeah, it's failing during... Not during the pushdown evaluation. Though the filter... So the filter is being pushed down. So it's semantically equal, but at the same point in time... So I wouldn't think that this would pass the referential equality check. Let's go take a look at our friend. It's going to be inside of optimizer. References. This is new subset dot references. What are the references? Control A, escape. Okay. We've got this. So what would the references be here? Newcond.references. Well, So expression. No, semantic equals. So they both need to be deterministic. And their canonicalized expression needs to be the same, but otherwise they can be different. So how do we make that the case? And then third, let me go take a look. We expected the reference is history 2-1 in our pushdown list. History is not null. 217 to be in the grandchildren set. Country history similarity. So here's the thing: we've got this, and presumably history 217, history 178, and this is some other stuff, are like semantically equal, but wait, to be in our grandchildren's set. Let's find the assertion. Thankfully, we know there's not a lot of assertions here. New cons. And so vowed grandchild. So that's, we are saying grandchild dot output set. Um, local relation. I need to be able. I don't 100% need to be able to make this a test where it fails, but it would be a lot better to make a test where it fails. Hmm. Not right. Filter. Yeah, but these are so. My problem. So let's go look at the query plan that I've got where it's failing. So it's got join. Oh, it's got a join. Is the join what's forcing these to be equal? This is going to be so annoying. Okay, history. Got country. Let's go. Wait. Is my failure? Am I debugging the right one? Because this is the union, and the join case should be different, right? This is the union case. Am I looking at the union case over here? Maybe I'm debugging the wrong one. No, this is filter union. So, and present grandchild is, okay. New cond is 3217 and new grandchild is 3178. So, where the fuck are these coming from? Oh, sorry. That's gonna drive me crazy. Okay. Yeah. I just don't know how 2 and 7 is semantically equal. Yeah, okay, so we've got a union of Okay, yeah. Okay, so in my code or in my sample query that I've got that's failing, um, that we don't have up on the screen, but we've got essentially something that's being cast. So we've got a projection. Yeah, so we have a union and we've got a projection. And since it's a union, we've got wait, okay, okay, we've got our union, right? Not by name. Um union union part 2 electric boogaloo, okay, whatever. Or wait, no, that got different electric razor. So we make a local relation. Timbit is awesome. Then we've got a filter on a, okay. You're going to be 10-bit, and you're going to also, so why is that not working out properly for us? Like, this seems to work fine. I think the reason why we're seeing a failure is I've got like this really weird syntax. I'm not super weird. As okay, actually, wait, we've got okay, what about a they want it to resolve to a different number. That's probably not going to work, but it's, yeah, okay. Okay, filter, push down suite, column. Scala. Yeah. 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 Not quite what I want. I want this to be a column with otherwise the same name, but like a different magic number. Although, does that matter? I guess that's... okay. Pushdown predicates. Is this like, oh, this is resolving. Doot as history. Fail, but okay. Oh. Let's go look at test 5 local relation. Okay. Let's see. Okay, so it can also take a start type. Char local relation SQL style associate test Scala. Let's go take a look over, trying to figure out how to like make more esoteric local relations for the purposes of trying to like figure out how to make this local relation symbol. Wait, this passed? Wait, what? Oh, that was test compile rather than test. Okay, yeah. That's why. So yeah. Cool. Okay. Hmm. Local. This is a logical plan. From external rows. No. Still gonna. So close. I really. Hmm. Okay, yeah. What about let's do some sketchy debugging here. Okay. So it's probably not actually going to show up, is it? Video println will show up when I run the test. I don't know. Let's make it fail. Set that to 7. So our test will fail. And we can. Maybe it'll give us our log messages if we set it to 7. I don't know. No. No log messages. Okay. Pushing down. Pushing down. Interesting. Println $e inside of $output. This should have to happen multiple times, though, shouldn't it? There we go, yeah. Matched A0. Yeah. Okay, cool. Yeah, so we see that happen twice. It's been magically converted, though, already. Their outputs Oh, Union's done some special. Oh, Union's done something special. Union's done something special. Basic. Logical operators. So, we've got our children. And then we've got, okay, Midland, looking at Union, grandchild. Okay, okay. Making slightly more sense. Duplicate resolve? Interesting, my friend. Interesting, my friend. Okay. But still, we're matching inside of out. Okay, yeah. We're still matching inside of the union output. So grandchild.out. Oh, yeah. Oh, this is not good. Not good. Yeah. Hmm. Okay, I have an idea. Maybe. By name, allow missing call. Okay, we're gonna go back over here to our good friend filter pushdown suite. Yes, by name equals true. Allow missing call equals true. Okay. Then what does this look like? This is not good. This logic, in fact, is going to be incorrect. I think for a filter pushdown. Oh, that's not great. Let's see. Does it produce reasonable things? I don't think it's going to. Don't think it's going to. But I could be wrong. So here we've moved. Yeah, okay, so this is null as a 0. Okay. So this is fine. Fine adjacent. Fine adjacent. Or wait, yeah, okay, we're going back to here. Union, okay. Up. There we go. Down. There we go. Union, false, false. So the union that I have in practice, where this is failing, these are both set to false. So that's not how we're getting it. But we do have a projection over top of an inner join. So, okay. Inner. Okay. These have. Okay. Okay, but okay, so this makes some amount of sense. And when we do this, do we get a reasonable looking result out? We get filter cast null as big int equals 2. And so, okay, let's go back to union. And we still have C. So C is still the one that's greater than 5. So that's fine. Although, let's make sure that's like fine. Oh yeah, okay, so it's just gonna make so this is getting the index. So this is assuming that the grandchild's output is the same as the output from union. But like, is that necessarily the case? It looks like it is. Let's go back to our basic logical operators. So when we call output, we get the children's output transposed. Okay, sure. Whatever. Okay, so this probably works. Here we go. Okay. Probably happening inside of rewrite constraints. So what do we do? So okay. Okay. I'm slightly more convinced this is reasonable, but now I'm still. Okay, so these two should be false somehow. Okay, rewrite constraints. Maps the constraints containing a given original sequence of attributes to those with a given reference sequence of attributes. So we go ahead, we say these two sets need to be the same, and then we do this rewrite. And attributes rewrite. Where does attributes rewrite come from? So rewrite constraints. For each child, we call rewrite constraints. And this returns an expression set, and then it gives us a set of valid constraints. Wait. So somehow the output, like that picks the right one. Hmm. Grandchild. Matched E inside of output. Matched E inside of output. So this is looking at union. Because this has got the by name, so now it's got this projection added in, and that makes everything line up. Okay, cool. We turn off by name, run this again. What do we get? Oh, but we're always looking at it inside of its relative position. Yeah. So that's fine. So we get the indexes and we match them up. And we say they should be semantically equal. And they should be. I don't think this assertion is needed. I really want to be able to trigger a failure of this assertion though, so that I can like prove that this assertion is wrong. But I'm having the devil of a time triggering a failure of this assertion. So we're saying new conned references should be a subset of I'm gonna just go ahead and escape. Escape. Fuck. Screen. Screen paste mode. Control A, page up. Go back in screen Linux up above. Okay. No. 0, control, alt escape. Nope, not it. Control Shift A, page up. No. Control Shift A. That's not what I want. Okay, Control A, escape, page up. There we go. That's the ticket. That's what I wanted. God damn it. Why is this so hard? Okay. So here's the deal. So these somehow okay. Looking at union grandchildren matched E inside of output. Okay. So optimizer.scala. Okay, new cont is new cont. New cont is not null history 217. Okay. So yeah, this does raise a question of how grandchild output can produce an element that's not inside of grandchild output set. Right. Like that seems like a reasonable assertion. Now, actually that I'm looking at this, right? So, okay, where is output set and output? Like, how could these be different? Yeah. That's great. So where is... So... How the fuck does this have... Oh, God. Where did this assertion come from? Okay, let's go get log minus p SQL core SQL catalyst asserts main optimize. I don't know. Catalyst optimizer optimizer.scala. Where do you come from? Okay, so this was done right now. So Davies added this in Spark 1487. Let's go take a look at that PR. Right, pull requests. Great. Um, uh, yeah. Huh. Could I? So the initial commit is this one. Let's see if that's in the initial commit. No. No. Here we go. Probably here. No, still no. Okay. Assert? No. Okay, this is in the files change, right? I'm not looking at the wrong. Okay. Yeah. I'm gonna find where the assert was introduced. Yeah. Okay. So let's go back to the comment right before this. So union. No. Don't care about this one. It's probably actually the previous one. There was mention of how this could be improved, right? So initially this union filter pushed down. Oh, it's different. Okay. Oh, actually interesting. I'm curious. So yeah, no, this used semantic equals. This can be simplified. So all attributes should exist in child output. But for whatever reason, our output set here is not like we're picking it off of the grandchild output, but somehow the grandchild's output set is different. Now, if I'm looking at this, my two things that are right here, the immediate parents, are both projections. And the one where it fails is right underneath the projection. So it's come through the projection? Fuck me. Oh. Computers, my friend. And this is Most disconcerting. Okay. So this is fine because you have history 178, 187. Who knows? Who cares? This one here. Oh, I will be right back. Door. Which I still have not figured out, like at all. Oh, yeah, it's this output set shit. So how do we get something like we've matched it? By pulling it out of grandchild, like new con comes from grandchild output, but GC set is somehow not the same. Oh, right, because it's that semantic equality shit again. Where, okay, yeah, this is making sense again. I feel slightly less crazy. So, why? Okay, so how do I make something? Although, wait, no, GC output, like, because I'm pulling this as off of GC output, and then I've got output set. What is... this is from a join, right? Yeah, this is from a join. It's gonna be join. Okay. Line error. No, it's actually inside of base logical operators too. Okay. Okay. This is output. What is sets? Okay. So which extends binary node, which extends with predicate helper. Okay. So, okay, I probably need to make a join over top of this and something else to make it fail. Ugh. Fuck. Okay. Filter pushdown suite. So join whatever EF and EC. Okay, EF, EC, inner join. Oh yeah, okay. Inner condition. Actually, I guess we could do condition is right outer, full outer condition none. Okay, let's go filter, pushdown suite, Scala. Let's go find another join. There should be another join inside of this. Ah, actually, that's much easier. Okay. Left. Okay. Left. Right. Okay, and then test relation 2 is equal to left.join right dot where subquery x y wait, there was one that looked less gnarly above. Yeah. Condition is equal to sum x dot e dot adder equals y dot e. Okay. Progress. Okay. Line 30. What? This line number doesn't make any sense. 34? No. It's 887. Okay, yeah. That makes a lot more sense. Okay. Right. Oh, yeah, okay. Computers. Oh. Oh, yeah, okay. Good. Hmm. Wait, what? We should have the same number of... Right? Because this should give us... has 4. Um, why does this have... fine. I guess. Reference E is ambiguous. No shit. Okay, okay. Oh, damn it, it passed. Which means that, like... oh. You're gonna be... I don't know. Actually, I'm making shit up right now. Okay, this looks closer. Kind of what I've got going on, except it's not. Quite what I want, right? It's also swap these two around. Still not going to fail, I don't think, but okay, we're making a bit of progress into understanding why. Right, I was going to try and figure out where optimize. Yes. Rep.var output set star sfc name. Yeah, def output set. Where do you come from, my friends? You, okay. Val output set? Fantastic. Somehow the output set and the output is different. Where is it defined? Where is it defined? Output set is lazy val inside of query plan.scala. Okay. Query plan scala lazy val output set is an attribute set over output. Is that the only one? It could also be alias aware output expression. Alias aware output expression. Alias aware. Yeah. I don't think this needs to be true. I can't yet make a test for it where it fails. We're getting closer, I think. So it wouldn't necessarily be a local relation. Or like a local relation is probably not enough. An inner join across, so join of type inner, one of them yeah, so this has got two serialized from objects. I don't know what they are, but same. They're semantically equal. But they're just not. Ugh, computers, my friend. They're the worst. Okay. So, we've made a bit of progress to figuring out what's going on. Not enough, mind you. I still don't have this, like, failing. Alexa, create a 6-minute timer. That's going to be our sort of cutoff. And then we're going to come back to this tomorrow, because after 2 hours on this, it's good. I feel like I'm missing something as to how the output set and the output could be different. It doesn't initially seem obvious. Okay, basic binary node. Okay. Delete. Okay. No, binary node. Is it not that? Binary node. Interesting. F-R. Oh, it's a trait. Okay. Extends logical plan with binary like logical plan. Okay. Logical plan. Output attributes, child attributes. I'm remembering now. Output set is attribute set. And over here, although it's private to this, so that doesn't. So output set extends query plan of type logical plan. So we go over to our friend query plan and we go look at output set is attribute set applied to output, which if we go look at optimizer.scala, we're looking at we're getting the output. So how is attribute set working? So attribute set is being applied to, what's it being applied to? Output, a sequence of attributes. So we apply it to a sequence of attributes, and we go ahead and we get the references. We call from attributes set full. Okay. So, I don't know how we're getting this mismatch with attribute sets. Alexa, how long is on my timer?
You have 30 seconds left on your 6-minute timer.
Okay. I don't think I'm gonna figure it out today. Um, Alexa, stop. Okay, so we made progress. We've got an idea how the union operator and filter pushdown are supposed to work together. We've got a bit of an idea why this assertion was added, although not a lot of an idea, honestly. If yeah, um, um, yeah, that's okay. That's okay. We've got some idea. We're not. I'm not super sure where it is that these things are no longer being equal. So um, in my world, um, so yeah, I'm gonna come back to this tomorrow. I'm gonna run a build overnight for the work thing where I've got this breaking. And that'll hopefully help me figure out what's going on here. In the meantime, I guess I need to figure out what the attribute sets are. New mutable linked hash set attribute equals. And um, huh. But yeah, actually, I'm realizing now. So this returns an attribute set. Oh, new con.references should be a subset of grandchild output set, but yeah, I really think that we need to either rip this out or use a different comparison. I want to be able to prove that by making a test. Probably actually what I need to do, because I want to prove this, that this check is wrong. Um, by creating a test would be, so the other way that we could do it is we make an attribute such that the attribute is equal okay, such that the attribute is equal, but it's not. I have an idea. We're gonna one last idea. Okay. Well, actually, no. So for future Holden, our plan, should we choose to accept it, which we probably will, but I might forget, is make it such that we've got two attributes that are equal. So our attribute set does not contain both of the does not contain all of our attributes, right? And by equal, I mean attribute equal. And so then that'll get kicked out. And then when we do the subset check, provided the one that we picked first is the one that gets kicked out, then we'll fail. This is my belief. I could be wrong. We're going to try it tomorrow, though, because it's 5:20 and it's been a long fucking week/year, and it's not. I'm tired. Tired, y'all. Anyways, that's a good reason to stop working for the day, to be clear. I like getting paid. Okay.